Hi everyone, today's lesson is on preparation and reactions of alkanes and alkenes. Alright, let's start off with preparation of alkanes. I will look into alkane first. Now, there are two ways whereby we can obtain our alkanes. The first method is called the catalytic cracking of petroleum. Basically, cracking is the breaking down of long chain hydrocarbon with heat or catalyst to produce smaller ones and hydrogen. Okay, so you have long chain hydrocarbon breaking down to give you the small ones. So petroleum is what we get from the ground. We learn this in the topic on fuels, and we break them into smaller molecules, and one of them would be alkanes. Now, so the condition required is high temperature. The key is high temperature. Although we put 500 degrees Celsius here, depending on the industry, sometimes the temperature may vary, but the key is high temperature, and you need silicon dioxide or aluminum oxide as a catalyst. Okay, so the big molecule will break down to become the small molecules. We will now look at one example. If I have a long chain hydrocarbon C10H22, okay, if I let it undergo cracking in the presence of high temperature and the catalyst, what I can get is possibly C7H16 plus C3H6. That's one possible way, one possible reaction. Another possible reaction could be it produces C10H20 and hydrogen. Okay, so you may wonder, how do I know which are the products that will be produced? Most of the time in the exam questions, you will be given information so that you can write down the equation. The key thing is the law of conservation applies, which means if there are 10 carbon here, the two numbers you add here, the total number of carbon before and after must be the same. And if there are 22 hydrogen altogether, the total number of hydrogen after that must be the same. Your elements cannot be destroyed or disappear. So in that same way, in the second reaction, the number of carbon is the same and the number of hydrogen is the same. Okay, so if we look into details, C7H16 is an alkane, and this is how we can get one of the alkane. And if you realize, this is not an alkane, this is an alkene. And from here you can see that actually later on, cracking will also be one of the methods to prepare alkene, which is on the right hand side of this piece of paper, which I will talk about later. Okay? Now, the second way of preparing an alkane is actually your reduction or addition of hydrogen reaction. So what I have here is I need to start with a alkene, which is unsaturated. And just to recall, or if you have not heard about this before, the word unsaturated means there is a presence of carbon-carbon double bond. Okay, which in this case, an alkene is always unsaturated because you have a carbon-carbon double bond. Now when I add hydrogen over to my alkene in the presence of nickel catalyst and heated at 200 degrees Celsius, you realize that my double bond opens up and the hydrogen is attached to it. So you can see that the hydrogen was added to the carbon-carbon double bond, and hence this is called the addition reaction. It's an addition of hydrogen from an alkene, okay, to start with, and you get alkane at the end of it. So the conditions and reagents are important, so please remember this. Okay, with this, let's look over to the right hand side to see how we can prepare alkenes. Alright, so I mentioned just now, cracking is one of the method that I can get my alkene. So it's the same, conditions is the same, so you can refer to what we did just now. The second way of preparing alkene is actually dehydration of alcohol. Alright, in the industry, the condition required are 350 degrees Celsius and aluminium oxide as a catalyst. So what happens is actually you realize that in your alcohol you have a OH. Okay, you have a OH and you have a H. Okay, they will be removed across. Okay, they will be removed to form water, and the two bonds here will form a double bond here. Okay, so this is dehydration. The word dehydration means remove water. Right, dehydrate. When we are dehydrated, it means that we are lack of water. So dehydration reaction, dehydration of alcohol, you will get your alkene. Now this is the industry preparation. There's also the lab preparation. So in the lab, we can also do this reaction in the lab. The conditions are slightly different. So you have 170 degrees Celsius and you use corn sulfuric acid. Okay, so for this part, you just need to be aware because the exact conditions and reactions, conditions and reagents are not required of you. Alright, they are not required of you, but you just need to know that I can remove water from alcohol and I get my alkene. Alright, and if you look at these two side by side, I'm just going to show you how, an overall picture of how we can prepare our alkanes and alkenes. Just one big note in the box below, you see here, in organic chemistry, for every reaction, you will need to remember the type. So when I say the type, it means the name of the reaction. For example, the type would be cracking of petroleum. Okay, and the type will be addition of hydrogen. You need to know the reagents and conditions. Okay, what's the temperature? What is the catalyst you need to add in? What are the things you need to add in? And of course, how the products are formed. In fact, you will see this is the key in organic chemistry, because once you know all this, you will be able to answer all the questions in organic chemistry. Okay? Now let's move on to the reactions. Okay? Sometimes we call this chemical properties, because chemical properties basically means the chemical reaction. So again, let's focus on alkane. The first reaction that alkane will undergo would be combustion. Okay, so all hydrocarbon will burn in excess oxygen to give carbon dioxide and water and heat, of course. Okay, so this is just a generic formula that represents this equation. I don't suggest you memorize this. My suggestion is you just write the chemical formula and balance the equation accordingly. Okay, let's look at the second reaction that is very special to alkanes. So only alkanes, according to your syllabus, only alkane will undergo substitution reaction. So the word substitution means there is a replacement. So alkanes will undergo substitution reaction with halogens. Okay, what are halogens? Halogens are your group 7 elements. So you can have your fluorine, you can have your chlorine, you can have your bromine gas. Okay, but it is in the presence of ultraviolet light, or sometimes the question says sunlight, to get a mixture of alkyl halides. Alright, so what are alkyl halides? We will look at it when we look at one example. So the reagents of course you need is your halogens, because you need to give the halogens for it to replace. and the condition is ultraviolet light. So using this, looking at this, let's look at one example. If I have methane, okay, methane, CH4, and I have chlorine gas, and I have UV light, okay, what will happen is one of the hydrogen will be replaced with chlorine, and you get chlorine with HCl as your product. So this is step 1. Alright, so you realize that your hydrogen was replaced with chlorine, so that's why it's substituted with chlorine. Now if I have plenty of chlorine, right? If I have plenty of chlorine, meaning I can still carry on my substitution reaction. Okay, so if this is what I have from here, I continue with more chlorine. Still UV light must be present. Okay, I will have now another hydrogen being substituted, and I get another HCl. Alright, so this carries on until all your hydrogens are being substituted. Alright, so this is called a substitution reaction. So I just want to say this again. Substitution reaction is one that is unique to alkanes according to our syllabus at O levels. Okay, now let's move on to alkenes. Alkenes have a lot more reactions, and the reason is because of the presence of carbon-carbon double bond. Now the first reaction, combustion, is the same as what we saw in alkanes. So in fact all the hydrocarbons were burned. Just now we mentioned just now, all the hydrocarbons were burned in excess oxygen to give carbon dioxide and water. Okay, so nothing new here. Same goes for your alkene. The second group of reaction, which we call the addition reaction, is unique to alkenes. In this case, it is addition reactions are unique to alkene, and the reason is because there is a carbon-carbon double bond present, which allows other elements to be added into the compound. Okay, so the first one, you have already heard about this when we talk about the preparation of alkane. So first one is addition hydrogen. You add your hydrogen. Okay, so you add hydrogen, you get alkane. Catalyst, nickel, and temperature is 200 degrees Celsius. So this is addition of hydrogen. The second reaction is addition of halogen. Okay, I can add Br2, I can add Cl2. Okay, this is different from substitution because this reaction takes place in the absence of light. Okay, you remember that in substitution reaction there must be UV light present, but here there isn't a need for light to be present. In fact, this happens in the absence of light. So the equation shows across the double bond, you add your halogen, which can be your Br2 or Cl2. So if it's Br2, then this will be Br and Br, and if it's Cl2, it will be just Cl and Cl. Okay, very clear. Now the third one that you can add is actually steam. The third reaction you can add is steam. Okay, steam, adding steam, and when you add steam, you get your alcohol. One of the carbon will take the H and the other carbon will take the OH, right? And you produce alcohol. So addition of steam, okay, you get your alcohol. So in order to add steam, your reagent, you must have steam, and your condition is such that you must have your phosphoric acid as catalyst, temperature 300 degrees Celsius, and at a pressure of 60 atm. Okay, so this is important. So the second one is addition of steam to produce alcohol, and these three addition reactions are very unique to alkene, and I mention this simply because they have a carbon-carbon double bond. All your things that you want to add can be added across the carbon-carbon double bond. Reaction 3, we will revisit this later on when we talk about polymer. You just need to remember there is another reaction called the addition polymerization. Okay, addition polymerization. So basically all your alkene will add together to form a very big molecule. Again, I say we will revisit this again when we look at macromolecules, which is the last topic. So with this, we have come to the end of this section, which is preparation and chemical reactions of alkanes and alkenes.